Welcome to G Fun Facts Online. Today, we're talking about an enemy you can't see coming. It travels silently, crosses borders without a passport, and leaves a trail of sickness and death in its wake. This isn't science fiction. It's the reality of the global spread of disease-carrying mosquitoes. These tiny insects, often just an itchy annoyance, are actually some of the deadliest animals on the planet, responsible for nearly 1 million deaths every year. This is the story of their invisible invasion, how it's being supercharged by our changing world, and the incredible science being deployed to fight back. So let's get into it. There are over 3,000 species of mosquito, but only a handful are the true villains of this public health drama. These key players belong to 3 main groups, or genera: Anopheles, Aedes, and Culex. Each has its own infamous resume of diseases. First up is Anopheles, the original public enemy #1 in the mosquito world. This genus is the primary vector for malaria, a parasitic disease that has plagued humanity for millennia. Caused by the Plasmodium parasite, malaria is still one of the world's most lethal mosquito-borne illnesses, claiming hundreds of thousands of lives each year, with a devastating impact on children under 5. Next, we have the Aedes genus, particularly the species Aedes aegypti and Aedes albopictus. These have become major threats in recent decades. They are the primary carriers of a whole suite of viruses. You've probably heard of them. Dengue fever, a brutal illness that now puts almost half the world's population at risk. Chikungunya, which causes excruciating joint pain. And Zika virus, which horrified the world when it was linked to severe birth defects. They also transmit yellow fever. The Aedes aegypti, or yellow fever mosquito, originally from Africa, hitched a ride on trade and travel routes to go global. Its cousin, the Aedes albopictus, known as the Asian tiger mosquito, is an even more aggressive invader, having spread from Asia to every continent except Antarctica. Finally, there's the Culex genus, the common house mosquito. These are the main vectors for viruses, like West Nile, Japanese encephalitis, and St. Louis encephalitis, all of which can cause severe neurological disease, leading to permanent disability or death. They also spread lymphatic filariasis, a parasitic disease that leads to chronic, debilitating swelling. So we have our antagonists. But the truly alarming part of this story is that their territory, their battlefield, is expanding. They are moving into new regions that were once considered safe. The single biggest driver of this expansion is climate change. Rising global temperatures are creating warmer, more hospitable environments for mosquitoes in places that used to be too cold for them. This means regions at higher altitudes and in more temperate climates, like parts of Europe and North America, are becoming new frontiers for these insects. Warmer temperatures don't just expand their range, they also speed up the mosquito's life cycle from egg to adult and accelerate the replication of viruses inside the mosquito. This combination means more mosquitoes, living in more places, becoming infectious faster. It's a perfect storm for disease transmission. It's not just heat. Changing rainfall patterns create more pools of stagnant water, which are perfect mosquito nurseries. Researchers are already tracking the northward march of species like the Asian tiger mosquito across Europe. This isn't a future problem, it's happening right now. At the same time, globalization has created superhighways for these tiny invaders. The eggs of Aedes mosquitoes are remarkably tough. They can survive for months in dry conditions, waiting for a drop of water. This means they can be unknowingly transported across oceans in cargo, particularly in things like used tires or ornamental plants. And of course, the rapid movement of people means an infected person can carry a virus from one continent to another in a matter of hours. If a local mosquito bites that person, a new outbreak can begin. What's fascinating is that this isn't entirely new. History shows us that temperate climates are not an automatic shield. In the 18th and 19th centuries, the United States saw massive outbreaks of malaria and yellow fever as far north as Massachusetts. Yellow fever alone is estimated to have killed over 100,000 people in the U.S. before 1905. During the Civil War, there were over 1 million cases of malaria among soldiers. These historical outbreaks are a stark reminder of our vulnerability. To fight an enemy, you first have to find it. That's the job of mosquito surveillance, a critical part of public health. For decades, this has relied on some clever, low-tech methods. Public health workers conduct larval surveillance, using a simple dipper to scoop water from potential breeding sites to see what species are present and in what numbers. They also use ovitraps. These are typically small, black containers with water and a strip of paper or a wooden paddle inside. Female Aedes mosquitoes, which love to lay eggs in containers, are attracted to them. By counting the eggs, officials can track the presence and population trends of these dangerous species. To catch adults, they use traps like the CDC miniature light trap, which uses a light and a plume of carbon dioxide from dry ice to mimic a living, breathing animal. It's a gold standard for capturing a wide variety of species. But today, these traditional methods are being supercharged with technology. Geographic Information Systems, or GIS, allow officials to map surveillance data and layer it with information on weather, population density, and disease cases to identify high-risk hotspots. Satellites can be used to spot potential breeding grounds from space, detecting changes in vegetation and water bodies over vast areas. Genetic analysis is another powerful tool. By sequencing the DNA of mosquitoes, scientists can track the spread of invasive species, understand how different populations are connected, and even monitor for the development of insecticide resistance. And increasingly, you can be part of the solution. Citizen science programs that allow people to report mosquito sightings or breeding sites through mobile apps are providing a wealth of data that helps public health agencies respond faster and more effectively. The human cost of this invasion is staggering. As of September 2024, the world had already seen over 11.5 million cases of dengue, a huge increase from the previous year. The Zika outbreak in the Americas showed the heart-wrenching potential of these diseases, causing microcephaly in newborns. The economic toll is also immense, from overwhelmed healthcare systems and lost productivity to the massive cost of control efforts. So how do we fight back? The most effective approach is called integrated vector management. It's not about one single magic bullet, but a multi-pronged strategy that targets mosquitoes at every stage of their life cycle. For years, chemical insecticides were the main weapon. Larvicides are used to kill larvae in water, and adulticides are sprayed to kill flying mosquitoes. But overuse has led to a major problem: insecticide resistance. Many mosquito populations are now immune to our most common chemicals, making them far less effective. This has forced us to get smarter. One of the most sustainable strategies is habitat modification, or source reduction. It's simple: get rid of their breeding sites. Since many key disease vectors like Aedes aegypti breed in man-made containers around our homes, community participation is essential. Simply emptying standing water from flower pots, old tires, bird baths, and buckets can have a massive impact. Another approach is biological control, which uses the mosquito's natural enemies against it. This can mean introducing mosquito-eating fish into ponds or using a naturally occurring bacterium called BTI, which is lethal to mosquito larvae but harmless to most other organisms. But the most exciting developments are happening in the realm of cutting-edge technology. Scientists are now using genetic modification to fight back. One method involves releasing sterile male mosquitoes that mate with wild females, whose eggs then don't hatch. This can cause a local mosquito population to crash. An even more advanced technology is gene drive, which can rapidly spread a desired trait, like infertility or resistance to carrying a virus, through an entire mosquito population. Then there's Wolbachia. This is a naturally occurring bacterium that, when introduced into mosquitoes, can act as a viral blockade, preventing viruses like dengue and Zika from replicating inside the mosquito. So, even if the mosquito bites an infected person, it can't pass the virus on. Large-scale projects releasing Wolbachia-infected mosquitoes in communities in countries like Australia, Brazil, and Colombia have seen dramatic reductions in dengue transmission. Technology is also upgrading surveillance and control. Drones are being used to map breeding sites in hard-to-reach areas and for the precise, targeted application of larvicides. Researchers are also developing smart traps that can not only capture mosquitoes, but automatically identify their species and even test them for viruses in real time, providing an almost instantaneous picture of disease risk. Ultimately, though, no amount of high-tech wizardry can succeed without community engagement. Public education is key, teaching people how to protect themselves with repellents and clothing, and empowering them to eliminate breeding sites around their own homes. The invisible invasion of disease-carrying mosquitoes is a global challenge that respects no borders. As our world gets warmer and more connected, this threat will only grow. It demands a sustained, collaborative global effort. We need to strengthen our public health systems, invest in research, and work together to track and respond to this threat. The pioneers of public health, like Carlos Finley and Walter Reed, who risked their lives to prove that mosquitoes spread yellow fever, showed us that understanding our enemy is the first step to defeating it. Today, a new generation of scientists is working on the front lines to turn the tide against this persistent threat. The fight is far from over, but through innovation, collaboration, and vigilance, it's a battle we can and must win. Thanks for tuning in to G Fun Facts Online.